records or reports? Reports, okay. Output table summary reports. You change this from all summary to all summary and monthly. Just for you know, this is only for advanced mode. If you really have very messy data you want to play with, you can manually make them to be organized and use a simple mode, or you just want to have more time in the code, then you go to advanced to do something like that.
Just to let me jump in here quickly, or did you already say that? So we have 4 students doing this, and they will do an additional step with the other tool that we are not going to talk about today, which will do the blind calibration, remember? So you compare your own calibration to this blind calibration. But we have a 5th student that will not do that, but and that's Saul, who couldn't make it today. He will do the calibration with the normal consumption data for a year, but then add 2 weeks of detailed data that we're going to measure ourselves in the building that he's looking at. And that's an interesting way of adding very detailed data for a short window to your calibration, and see if your calibration gets any better by doing that. And so, and it's interesting so that you all learn a little bit from his experiences, and that we also do this other blind calibration. So that is how we set up the group, the differences between those 4 students that are doing calibration. So we all learn a little bit from each other. But it also means that she has to apply that advanced option to make that possible, that somebody can calibrate with 1 year of consumption data, as you have already been doing the whole time, also with ETC. But also then throw in 2 weeks of very detailed data. And that makes life for Chi harder, but he apparently got it to work. So there will be 1 student using that advanced option.
Okay, thanks. So you can see now the difference between these 2 files. One last thing about the advanced file, which is the next object called output control table style. The default is HTML, which basically you open the file, it is shown in your web browser as a file you can browse. You can go into and change it from HTML to comma and HTML, which basically generate the same table file, but in 2 formats. One is still the HTML file you can open in Chrome, for example. Another thing is actually a CSV file, which you can open in Excel. And this is the file the code will read from that table. That's the 3rd thing about this advanced model. So, okay, I will close this too. So go back to these files. I also put the advanced file in the ePlusSim folder, which is right here. So just now we already see the simulation from the 15 minutes file. If we go to advanced file, right here, make sure the weather file is okay, and then you can simulate it as well. It basically changes nothing but the output thing, so it has more output for the moment. Let's wait for another minute.
So all these files that you're showing, will they be uploaded on T-Square, or did you make your own drive available?
I put it in OneDrive, and I share my link to them via Facebook. So I think they have access to that already.
Should we send this link over T-Square?
I sent this by email to you already.
When did you do that?
Like half an hour before class.
Oh, okay.
Sorry.
Okay, I will put that on T-Square and you can go there. Christopher has a question.
I noticed in the demo that your input units are in joules, like a metric. If I use inch pound, because on my data is an inch pound, will it matter? Or is it just like a number? It doesn't matter.
Sorry, can you say that again? Ng plus file?
In the Excel demo thing?
Excel. Oh.
Yeah. All the data you have there is in
Oh, you go way beyond what I'm talking about right now. I will cover your complete my simulation. If you see now, they have actually 3 outputs. When you open table, instead of HTML file, this time it will be Excel. You see all the same outputs, but in a different format. And if you go to something like you see all the monthly output right here, so which my code will then read them if you are doing some monthly calculation. But by the way, yeah, if you don't want to bother with the advanced mode, you can still use the output meter file only output, but then specify the reporting frequency to be monthly. Then it will do the same thing. Then you don't need to bother with all these table files. I cannot find it right now, so I will just let it go. And then check the other outputs. For the meters, you should have these 3 output: electricity, facility, like district heating facility, district cooling facility. The default is Joule, like you mentioned, is in matrix, but you can change them in the simulation setup to make it to be more in Edge Plus. It really depends on your choice. You can make both consumption data and output to be the same unit in inch pounds, for example, or you make them both in the international metrics. As long as they are consistent with each other, it's fine.
But well, I was just concerned that there might be like some subcoding that required it to be metric for it to or something.
In the output, I will explain that later. Yeah, but for now, okay, we check the files in the meter. Then we can also go to the variable. We see there are 2 outputs: zone air temperature. This is what we specified just now, and it is hourly. While, sorry, I forgot to mention that in this meters file, it is 5 minutes data. This is the time step I'm assuming using. So, okay, that's how finally, after we've done many things in Edge Plus, it's almost there. We have a good model. Now the next thing is to specify the parameter you want to change. You want to get it tuned by the script. So in doing so, we should go back to our simple, 15 minutes model. Open in text editor. Okay, let's see, you want to change occupancy. You find the right object. For example, if this is the value, you want to mark it as an input so that instead of the default 0.05 value, you want to make it range from something else. The simple marking is like this: 2 pounds in front, followed by the index 1, means this is the first parameter I want to calculate, followed by 2 pounds, and right behind the value, but in front of the comma, have another 2 pounds. So basically, this 2 pounds just like a delimiter. So basically, specify the index of your parameter and the value it should choose. It should change. Sorry. The same thing. Go for a second occupancy. If you say these 2 zones are different, so I want them to have different occupancy density, then this should become your second parameter. So that then the code will know there are different parameters. I will change them individually. No any correlation. But if you say, okay, I don't want to bother with these differences. I just want to treat them as one same space type which has exactly the same occupancy. Then doing the same thing, except this you mark this still also as 1, which means this is still also the same, the first parameter. Then my code will then treat them as one value. So it means every value I put into this one, I'll put the same value in this one. So it's totally up to your choice. So down for the people, I think they might be different, so I put it in a separate parameter and go to lighting. Okay, I put the 3rd parameter right here, doing the same thing. And for equipment, maybe I think I'll just put them the same. So they are shared by the same parameter. Okay. Sorry, it should be pounds, not dollar. So just like this, and then you save your file, this file as another file, which you need to specify later in the Excel specification. Save. So that's what you will see in the new file called demo 15-minute MD modified. If you open this, if you open the text editor, you go to see something, you will find they are already marked. Like, I have two parameters separated for two occupancy. I have the third parameter for the lighting density. I have the fourth parameter for the same equipment density, electricity equipment power density for the two zones, and I have a fifth parameter for the infiltration rate. These are my 5 calculation parameters. Okay. We cannot simulate in NGPath anymore because we messed up with this file with these 2 pounds, so it's not a valid IDF anymore. But somehow my script will read these pounds and find the value, change the value, and remove this pound, so it will be a valid IDF for simulation later. Any questions so far? Okay.
So the choice of your calibration parameters is, of course, the whole secret sauce of calibration, right? So you have to motivate and write a little section in your report how you, based on the EPC calibration, you got your best possible choices of calibration parameters, and you will probably iterate. If you cannot come close with your energy plus, calibrated energy plus model to the given measurements, then you probably have to choose another set of additional set of calibration parameters. So this is not something that's easy. That's basically the whole secret science of auditing or calibration. Calibration is part of auditing, making the best possible model of the building. So look at this as a very essential task that you need to do here.
Thank you. So now we are done with NGPlus. We have a new IDF file. So we have a roundable or good model NGPlus file. Then we save it as another version with our own marking of these parameters. Now you make sure it sits in the E+Sim folder. For now, it is the 15-minute MD. I also create the same thing with same parameters for the advanced model, which is demo advanced MD.idf. Now the next thing is we're doing is called CalSpecs, calibration specification file. Here is a demo file I showed you today. There's another blank file you will use to input your own data. So first is specification and NGPlus directory. I think we should be all the same on this one. Maybe not, because yeah, you see the program files. I think the default directory is program space files, but I messed up something, so actually I installed NGPlus in some place else.
Okay, nice to make it a little bit more complicated.
Yeah, you can. I think the default is actually C,
Yeah.
and then NGPlus.
Yeah.
But yeah, I don't want my personal preference.
Okay. Well, as long as they know that they need to be careful with that.
Yeah, just no space in this. And the second is the NGPlus model name. The name is the exact same file. Don't forget the .idf, and make sure it puts in the E+Sim folder. The third one is the weather file name, which is a default. It's not a default. It's just the original TMY3 file name I have here.
Yeah.
Make
Now-
sure. Sorry.
No, go ahead.
Make sure it puts them in the folder of the original NGPlus weather data folder. I recommend that.
So but we know that we have a problem here, right? Working with TMY3. Because it's not the weather that occurred during our calibration.
Yep.
Did you already mention that?
Yes.
Okay. Because everybody's looking, we know that. No, but so to do this right, or did you mention that also, that we should use the historical weather file?
I'm not sure what are their consumption data covers, but we have until 2014.
Yeah.
I have 2016 data, weather data.
is all our consumption data from 2016?
Yeah.
Could you share that? So, because it's really, it doesn't have to necessarily matter much, especially if you take monthly averages, like we did in the EPC. You remember I told you we were doing something wrong in the EPC by just using PMY 3, but we got away with it because we were calibrating for monthly totals anyway. And the monthly total would not deviate that much, or at least the 12 monthly totals would be a reasonable statistical average over the 2016. So we said it's wrong, but we get away with it. But here, we really have to be careful. If we're going to calibrate on real consumption data for December 2016, you cannot take the December month from TMY3, because December 2016 may have been a very, very cold or very warm month, and calibrating with the statistical year would be adding quite a bit of inaccuracy to the calibration outcomes. So maybe we want to find a little procedure to take this, is it already in EPW format?
Yes.
Maybe we should put that file that Christopher will share in that directory.
That'd be great.
And then we give it a name, and the name is put in this
Yep.
Excel column, okay? So this is something that she will do, and update this.
Yeah. You can just put the file name right here and then make sure this file actually sits where your Nginx file is. So in my case, it will be under C, program files, Nginx A60, weather data. This one. Yeah. Make sure it sits exactly in this place.
So we will share that file. You can download it from T-Square and put it where it should be, and modify this file, this Excel, with the file name. Okay? Simple.
Okay. Next step is measurement reporting frequency. This makes some difference. I only mentioned two modes, monthly or sub-hourly in the tutorial. So basically, you have very organized data. You just want to use either calibrating only to monthly data or calibrating only to sub-hourly data. If you want to mix these two, those are the best. Or unfortunately, if you only have monthly data, but it's not a whole year, it's instead of January 2016 to December 2016, you have data from like July 2015 to June 2016, you may still want to go to advanced mode because they are not continuous in this. Either you do something with your EPW or you go to advanced, which I don't know if we will encounter, but in that case I can maybe show you later in another study session.
Yeah, I think that almost everybody should be able to get away with the simple mode, just running from January to December 2016.
Okay.
And when you say sub-hourly, if you do it in hourly,
It's the same.
that's what you support, right?
Yeah.
That would actually be my advice, to take the measurement data and map it into hourly. So the 50-minute or whatever you have, map it into hourly totals or hourly averages. This is another tricky issue. Understanding, what the unit is of the thing. But it's up to you. But I would do that. That the sub-hourly 50-minute data that you read that is recorded, to aggregate that per hour is actually the better way of doing this.
Yeah, I might realize I forgot to differentiate average or sum for the hourly mode. I will change that later.
Yeah, it's tricky, yeah.
That's tricky.
Yeah.
So if you are doing monthly calibration, you're totally fine now. You can just go to the next tab. Otherwise, if you are doing sub-hourly for like 15 minutes data, you need to specify the following 4 things. First is about simulation time step, which is the value I just changed in the file. If you remember, you can put it's either 4 or 12. Okay. And then measurement time step, which means if it's 1, it means 1 point per hour. If it's 4, it means 15 minutes. 4 points per hour, which means 15-minute data. So this is a simulation time step. This is the measurement time step. You can make them be the same to make your life easier. Here is a little bit manual work, which means data start and data end. Okay, what are these numbers mean? Unfortunately, it means the exact location of a data in the output file. Because when you're calibrating 15-minute data, I don't think you will calibrate a whole year of 15 minutes data, which is too much. So you have to specify where they are located in the output file. Let's get back to our simulation file.
Well, I think the standard approach will be that we have only hourly output and hourly measurements.
Yep.
That, that makes things very straightforward.
That'll be great. Yeah, so actually I just mentioned briefly here, if you are calibrating to monthly, and you go to observation monthly, you can choose the type of the value, which month they are, what are the actual number, and what are the units of this connection. I only support 4 kW, kilowatt hours joule, giga joule, and kBTU. That's only 4 units I support, and I can recognize them and do the conversion correctly. If your data is outside of this 4 unit, you have to convert by itself to be 1. That's for monthly, so it's very flexible. You can choose whatever output you have, specify which month it belongs, and put the correct value. But for the hourly calibration, we go to our original simulation file. What is this? 15 minutes. I'll open the meter file. Assume I have the whole consumption data of June. Okay, so go manually to June 1st. And here it is. You can see.
We have about 5 minutes.
Yeah.
Just so that
You basically find out where your data is and find the index of it. So in this case, my first data starts from this, which will be 45,506. You put the value into data start. And the corresponding value for the last day of June, which is June 30th, will be the last value you use in this. So, yep, that's the 2 values you put in the range. So the code will know where to read this data. And correspondingly, you go to observation, observation sub-hourly, you put the corresponding value right here. You just paste, you copy and paste. You can also specify the output unit, the same 4 choices you have. Also, so because you specify the 2 things here, so I can do the correct conversion to match these 2, so you can calculate. Won't be having any problem. Should I also explain advanced, or I just go forward to see this?
Yeah, maybe I think that if the students stick to all the hints that we gave them here, they don't need to use advanced. Sol is the only one in the second stage, when he adds the own measurements, that will usually advance. And I think we need a separate session for that, just with Saul or with the whole group in a separate session. So,
Yeah, go ahead.
In the demo, I've noticed that there's observation, sub-hourly sin, and then sub-hourly.
Yeah,
but it's
forget
not-
about the sin.
Forget about it?
Forget about it, because you only use the calspec dot SLXS, which does not have that.
Okay.
So, okay, then we go to parameter, which actually the 5 calibration parameters you want to calibrate. You can name it by yourself. This name doesn't matter. What matters are the values. So you have a default value, which the calibration will start with. You give your minimum and maximum value for the range. And this index are the parameters and the index parameters I use. So they do not need to be from 1 to 5. You can specify your own sequence, but make sure the number you put here for each parameter is the same as the number you put in the IDF file. Remember, right?
and these ranges are, of course, again, informed by your understanding what is the physical range, what I think is plausible, just as we talked about in the EDC, so that you do not find calibration parameters outside of the range that is plausible, so that you get totally physically implausible results. Well, sometimes you do that on purpose. You want to not constrain the parameters just to see how good is my model in the first place. Then you find that you can only get it right by putting in a negative occupancy somewhere. You know, then you're sure that you're in trouble with the model.
Okay.
Or negative occupancy is probably not even possible, but I mean, you know what I mean, negative lighting depth,
I use the
whatever
same
it is.
example. I use the same example.
Yeah, okay.
So now we are okay for this hourly calibration. We only need to care about the specification tab, the parameter tab, and the observation sub-hourly tab. Only 3. So first you do the specification. The second you do the parameter. The third you put the consumption data. And then we are done now. Save your file. For now, this is also CalSpecs demo. And just save it. Then finally, we go to Enterprise. Sorry, MATLAB.
While she is starting that up, it's of course now interesting to see that on Wednesday we saw a visual programming approach that basically did many of the same things. Only, you were only doing it by creating little boxes that had inputs and outputs. Of course, there's a lot of things happening under the hood in each of these boxes that wasn't shown on Wednesday, so it's not that simple. But in any case, you could get away with doing this without touching MATLAB or any specific programming language. But it is just interesting to see how these two worlds are slowly converging. This is the traditional hardcore auditing optimization world that does it by having MATLAB and Energy Plus work together. And then we have the new crowd, the parameter jockeys, as I always refer to them, that come up with these visual programming, grasshopper-based approaches, where you don't have to get your hands so dirty in the logical programming, but more and more of these boxes are already shared between developers, so you get a lot of ladybugs and honeybees for free to do many of the same things. But that's very much in design exploration, whereas this is in the hardcore auditing calibration world. But they're slowly converging. So at the larger scope, it's good for you to see these two worlds, each using their own set of tools.
Okay, thank you. So you can simply double-click the cal exe file which we're opening and MATLAB, or you can open MATLAB and find it to the directory. But make sure this is what is showing right here. Current folder is the folder where everything is. Don't go to subfolders. should make sure that way. And then everything else is very simple. You barely need to do anything in MATLAB, only by changing the specification name to be your own Excel specification name. And it's called result name, which will save everything happens in MATLAB into a file which you can access later. You can give the exact whatever name you want. I explained these 3 parameters in the tutorial. You can refer to them later, but basically you don't need to change anything other than the maximum run, which means for here it's 10 means I only want to run my simulation 10th. I don't want to exceed that number. So if I stopped at this number, I put 10 here, which means after 10 runs, even if I don't find my optimal value, I will stop. So as to prevent from endless simulation you will never imagine. So actually I will recommend this value to be 100. So which means I run my simulation 100 times. Either I've already found my optimal, stop that, or I stop at the 100 time at the best.
Unless you choose 100 calibration parameters, then you definitely need to up that number to 10,000, okay? But hopefully you're not getting into that. Okay, we need to round up, please, sorry.